Okay, so in this lesson, we are going to shift from talking about shapes in 3 dimensions and how to describe them to how to use shapes in 3 dimensions to find something called surface area. So we talked a little bit about what a prism is, but the definition of a prism is that a prism is a polyhedron with 2 congruent parallel faces. And these faces are called the bases of this prism. The other faces are lateral faces. So lateral means outside. So lateral faces I think about as being around the outside of the shape of the polyhedron. So when we talk about finding the surface area, we have to find the area of all of the faces. So we find the area of the bases and then all of the faces. The next thing to know is something we've talked about before, is something called an altitude, okay? An altitude of a prism is a perpendicular segment that joins the planes of the bases. The height of a prism is the length of an altitude. A prism may be either right or oblique. A right prism, the height is an actual edge. An oblique prism, we think of as almost like a slanted prism, where the height is not an edge. The height is an imaginary perpendicular that shows us the vertical height of that prism from base to base. So in a right prism, the lateral faces are always rectangles, but in an oblique prism, some or all of those faces may be non-rectangular. So we can assume that a prism is a right prism unless I say otherwise, essentially. So in example 1, it says to use a net to find the surface area of a prism. Now this is mostly optional when you do these problems, but I'm going to give you a strategy. So the surface area of the prism is the area of all 6 of these faces added together. So I'm going to draw a net, and that net is going to start with, if I think of this as a room, like the back wall of this room, the back wall of this room is going to be a rectangle, and it's essentially like I'm unfolding this shape. So it's going to have a face to the left, a face to the right, a face above, a face below, and I am actually missing one face. I'm missing the front face of this shape. So I'm just going to draw the front face over here to give myself some room. So I understand this can be a little confusing, but it's essentially like unfolding a box. So if I'm talking about this as the front face, it's going to be 4 centimeters wide, 5 centimeters tall. So these are all lateral faces. All 4 of these are lateral faces, all right? So this one is 5 by 4. The other rectangle, this is and I'll erase this really quick to show. This represents the front. This represents the back. This represents the left. This represents the right. The top one represents the top. The bottom one represents the bottom. So the left kind of wall or left face is going to be 3 by 5. The right one is also going to be 3 by 5. And then the top and the bottom are both going to be 4 by 3 rectangles. So essentially, I just find the area of all 6 of these rectangles and add them together. So the area of the top and the area of the bottom is going to be 4 times 3, which is 12. 12 times 2. Okay? That's the area of the top and the area of the bottom, because there's 2 of them. The front and the back, 4 times 5, which is 20. And since there's 2 of them, I multiply by 2. So this represents the front and back. So top, bottom, front, back, and then I'm going to add on the left and right faces. So 5 times 3 for the left and right, they're both 5 by 3, so 15 times 2. That's the left and right. Okay? So if I add all of these together, And I'm going to do this in blue so you can tell the difference. That's 24 plus 40 plus 30. So 24 plus 40 is 64. 64 plus 30 is 94. So 94 square centimeters is the total surface area. Now, I will admit, this is a fairly tedious way to do this. If you get better at visualizing shapes, finding the surface area becomes a lot easier, okay? So we're gonna use some formulas to help us with that. So one thing I wanna talk about next is lateral area versus surface area. So the lateral area is really the product of the perimeter of the base and the height of the prism, but really it's the area of all of the lateral faces, okay? The area of all the lateral faces. So the surface area minus the area of the bases. The total surface area is the lateral area plus the area of the bases. So basically, it's gonna be the perimeter. You could do the perimeter multiplied by the height to get the lateral area. That makes it a little bit easier, and I'll show that in the next example. So in example 2, we're gonna use that lateral area formula. So I understand you're gonna have to kind of flip back, but the lateral area, you're gonna see why this is useful. It's the perimeter of the base times the height. So we're finding the area of all of these rectangles. And if you see the shape, it's a 6-sided base. It's a hexagon base. It means it has 6 lateral faces. So essentially what you're doing is you're taking the perimeter of the base, which is 6 times, which is 6 times 6. So the perimeter of the base is 36 times the height, which is 12. So 36 times 12 is the lateral surface area, 432 square meters. Another way you could think of this for the lateral area is you could find the area of one of the lateral faces, 6 times 12, which is 72. That's the area of one of the faces, and then multiply that by 6. So if I do 6 times 12, that's 72, times 6 is still 432. So that's another way to do it, is I am just finding the area of everything but the bases. So it helps with a complex looking one like this because it really makes our work more efficient. So I was just finding the area of these rectangles that are around the outside. Okay, so that's mostly what we're gonna work on, is finding the entire surface area and then just finding the lateral area. The only other thing I would like to talk about is to find the lateral and surface area of cylinders. So the lateral area of a right cylinder is the product of the circumference of the base and the height of the cylinder, okay? Because if we think about lateral area before, I said it was the perimeter of the base times the height. Circumference is the perimeter of a circle. So that represents the perimeter of the base. And then essentially, all you're doing to get the surface area is you're finding the lateral area plus 2 times the area of the bases. Because there's 2 circles, that's why it's 2 times pi r squared. You're finding the area of 2 circles. So in example 3, finding the surface area of a cylinder. I'm going to keep that formula visible up there. It says the radius of the base of a cylinder is 4 inches. Radius is 4 inches. Its height is 6 inches. What is the surface area of the cylinder in terms of pi? So we're finding the total surface area. So that is the perimeter of the base times the height. So pi times the diameter times the height. So pi times the diameter, which is 8, times the height, which is 6, plus 2 times pi times the radius squared, so 4 squared. So I'm going to do my work to keep this in terms of pi. So in terms of pi, pi times 8 times 6 is 48 pi. So that's the lateral area. And then what I'm adding on is the area of the bases, 2 of them, 2 circles. The area of 2 circular bases with a radius of 4. So this is 2 times 16. 4 squared is 16. 2 times 16 is 32. So 48 pi plus 32 pi is going to be 80 pi. And the one thing that I want to add on to this is obviously the units. This is in inches squared for my units. So I was using that formula. Pi times the diameter times the height, 2 times pi r squared. So understanding this conceptually, what the parts of the formula mean, rather than just thinking, I'm plugging in this, I'm plugging in this, I'm plugging in this. You have to think about what each part of the formula means. The first part is the lateral surface area. Just the lateral area. Pi times the diameter times the height. Second part, the area of both the bases. The bases are exactly the same, identical circles. So 2 times the area of those bases. So I actually make it a little bit easier for example 4, having us just find the lateral area. So the lateral area. So just a quick reminder, the lateral area is pi times the diameter times the height. Okay? So really all we need to do is talking about a roller, like even a paint roller. What area does it cover if I make one full turn, one full rotation? We have a height of 1.5, and we have a diameter of 2.5. So to get this rounded to the nearest tenth, I'm finding the lateral area. I don't care about the bases. The bases don't do the rolling. The lateral side of that cylinder does the rolling. So this is going to be pi times the diameter, 2.5, times the height, 1.5. So the lateral area of that roller to the nearest tenth, I just literally in my calculator do pi times 2.5 times 1.5. So rounded to the nearest tenth, this is going to be 11.8. It was 11.78, so I'd round that up to 11.8. And that's going to be in square inches squared. And I could actually write that a lot better. 11.8 inches squared. So lateral area is just the area around the sides, the area of the whole shape minus the area of the bases. So we're not finding the area of the bases in that example. Surface area, take the lateral area plus the area of the bases, and then you've got it. So what helps with these formulas is to get more practice. So you're going to be assigned a practice. Make sure you do the problems that I list in the instructions, and you should be then ready for the checkpoint.